Hey there! Thanks for stopping by. Let's dive into something amazing together. Welcome to Next Gen EduBuddies. Don't forget to hit those buttons below to stay connected. Like, comment, subscribe. Let's keep exploring together.
Oxygen, symbolized as O on the periodic table, is a fundamental element crucial for life. Oxygen's pervasive presence and importance are evident across the Earth. The abundance of oxygen supports diverse ecosystems and biological processes on Earth. Oxygen plays a vital role in respiration, combustion, and numerous chemical reactions essential for life and industry. Oxygen exists in Earth's atmosphere as a diatomic gas, denoted as OR. Diatomic oxygen, OR, constitutes approximately 21% of the air in Earth's atmosphere. The diatomic molecular structure of oxygen is essential for respiration processes. The OR molecular structure is also crucial for combustion. The presence of diatomic oxygen supports aerobic life on Earth. The double bond in OR contributes to its stability and reactivity. Oxygen is essential for cellular respiration, the process by which organisms convert nutrients into energy. During inhalation, oxygen is transported to cells via blood cells. Cellular respiration uses oxygen to power energy production within cells. The conversion of nutrients into energy through cellular respiration sustains life. Blood cells deliver oxygen to cells, facilitating the energy production process. Plants and algae replenish atmospheric oxygen through the process of photosynthesis. Photosynthesis converts carbon dioxide and water into glucose and oxygen. Sunlight provides the energy required to drive the photosynthetic reaction. Photosynthesis completes a vital life cycle by producing oxygen and glucose. Oxygen production is a collaborative effort between terrestrial and marine ecosystems. Forests are major contributors to global oxygen levels through photosynthesis. Phytoplankton in the oceans are also significant producers of oxygen. Terrestrial and marine ecosystems work in tandem to maintain global oxygen balance. Oxygen is a critical medical gas used to treat respiratory conditions. Oxygen therapy supports patients who require breathing assistance. Oxygen tanks and related equipment are essential components in healthcare facilities. Medical oxygen is administered through devices like nasal cannulas and masks. The provision of oxygen ensures adequate tissue oxygenation in patients with respiratory distress. Oxygen functions as an oxidizer in rocket fuel, facilitating combustion. Combustion generates the thrust required for space travel. This application highlights oxygen's role in high-energy processes. Oxygen's capacity to facilitate combustion is essential for rocket propulsion. Oxygen is utilized in industrial welding processes to generate high-temperature flames. These high-temperature flames melt and fuse metals together, creating strong bonds. The welding process demonstrates oxygen's capacity to support intense combustion reactions. Oxygen's role in welding highlights its importance in industrial processes requiring high-temperature reactions. Oxygen is essential for the survival of fish and other aquatic organisms. Oxygen pumps are used to maintain adequate oxygen levels in aquariums. Maintaining appropriate oxygen levels is important for the health of aquatic ecosystems. The introduction of oxygen supports the complex biological processes within an aquarium environment. Combustion requires oxygen to sustain a flame. A candle placed in a sealed jar demonstrates the consumption of oxygen during combustion. As oxygen is depleted within the sealed jar, the candle flame diminishes. The candle flame extinguishes when the oxygen supply is fully depleted. This demonstrates that oxygen is a necessary component for combustion to occur. Without a sufficient supply of oxygen, combustion cannot be sustained. In the upper atmosphere, oxygen molecules, OR, are converted into ozone, OSAN. Ozone, OSAN, forms a protective layer that shields life on Earth from harmful ultraviolet UV radiation. The ozone layer is vital for preventing UV damage to terrestrial ecosystems. The formation of ozone from oxygen is a continuous cycle in the stratosphere. Ultraviolet radiation is absorbed during the ozone formation process, reducing its intensity. The ozone layer's thickness varies based on altitude and geographical location. The ozone layer absorbs UV radiation. Ozone molecules convert into oxygen upon absorbing UV radiation. Oxygen molecules reform into ozone, continuing the cycle. This continuous cycle reduces the amount of harmful UV radiation reaching the Earth's surface. The ozone layer acts as a shield, protecting life on Earth from dangerous UV rays. The ozone cycle is a natural process that maintains a balance in the Earth's atmosphere. Pollution from factories and vehicles can disrupt the balance of oxygen production and consumption. Pollutants released into the environment can damage ecosystems. Environmental pollution reduces photosynthetic activity in plants. The disruption of oxygen balance and reduced photosynthesis contribute to environmental degradation. Damage to ecosystems and reduced photosynthetic activity are major consequences of environmental pollution. Deforestation reduces the number of trees available to produce oxygen. Trees produce oxygen through photosynthesis, a process vital for atmospheric oxygen levels. A decline in the number of trees leads to a decrease in both local and global oxygen levels. Reduced oxygen production from deforestation impacts the balance of atmospheric gases. Ocean dead zones are caused by nutrient pollution. These dead zones reduce oxygen levels in the water. Reduced oxygen levels harm marine life. Ocean dead zones disrupt the balance of oxygen production in aquatic ecosystems. Nutrient pollution leads to oxygen depletion, creating uninhabitable conditions for marine organisms. A healthy Earth, characterized by thriving forests and oceans, is fundamental for maintaining stable oxygen levels. Sustainable human practices play a crucial role in preserving the Earth's ecosystems and ensuring a consistent oxygen supply. Conservation efforts are essential for protecting forests and marine environments, which are primary sources of oxygen production. Responsible resource management is vital for ensuring a stable and continuous supply of oxygen for future generations. Maintaining oxygen levels requires a holistic approach, encompassing environmental protection, sustainable practices, and responsible resource utilization.
Don't forget to click subscribe and join the family. There's so much more coming your way. Subscribe now and never miss out on the fun.